Welcome students to Solving Quadratic Equations, and we're going to be looking at several methods for solving, including the quadratic formula, taking the square root when you have no linear term, difference of squares, and perfect squares. We're going to go ahead and start with quadratic formula because it's probably the most familiar to you. Now, no matter what method you use, especially if you're using quadratic formula, you basically have three scenarios. Your quadratic might hit the x-axis twice, which gives you two real solutions. Generally, when you're solving, you are solving for the x-intercept. That is the ugliest arrow ever. Don't be afraid to disagree. Or you could have one real solution. And that's if it is hitting at the vertex right here. That is one real solution. Or you have a scenario where it does not touch the x-axis at all. So it's either entirely above or entirely below, and these could turn upside down, by the way. They don't have to look like this. So you could have no real solutions. Oh my god. Which means you actually have two complex solutions. So you learned about this in Algebra 2, actually. You probably remember maybe learning about the number I, and you learned about it in this context. Complex solutions of quadratics. So let's get into that first. I'm going to start with the quadratic formula. So the quadratic formula. And you can use this when your equation is in standard form. So that looks like this. So you want to have your x squared term, your linear term. Now, this will still work if the linear term is missing, like if you have something that looks like this, but there is an easier way to solve that than quadratic formula, which we will get to next. Then plus your constant, and you want it to equal 0 to use quadratic formula. So, see if you remember this puppy. Negative b plus or minus the square root of b squared minus 4ac all over 2a. What you do for the quadratic formula is plug in the b's, the a, and the c, and then work it out, see what you get. So let's try one. We're going to start with one that is already in the correct form. So I will kind of show you what is what here. So here's our equation. Go ahead and take a second to write that down. And I have my ax squared, and in this case, a is 4, plus bx, and in this case, b is 6, and plus c. C is negative 40 on this example, and it equals 0, which is what we want. So I'm going to plug in each of these. X equals, and it says negative b. So I'm going to take my b and just flip the sign on it. So if it were already negative, it would become positive, but since it's positive, it will become negative. So negative 6 plus or minus. Plus or minus means you're going to have to do this operation twice, once with a plus and once with a minus. There is not, to my knowledge.
Hold. We are on a hold.
I love interruptions. Where was I? I don't remember. Anyway, go ahead and finish with your square root, b squared. It's a good idea to get into the habit of putting your b in parentheses, because when it is negative and you square a negative, you have to remember to put it in parentheses. Then minus 4 times a times c all over 2 times a. Looks like a mess, but now all you're going to do is take it step by step. So x equals, now leave this alone, we're going to work on the part inside the square root first. So we are just using PEMDAS, which means start with your parentheses, which is everything in here. Then your exponents, which other than the square root is actually part of the exponent step, the square root itself. Then we're going to multiply or divide. So start here. Just leave the -6 plus minus for now. And go ahead and do 6 squared, which is 36. And then I'm going to go ahead and multiply -4 times 4 and then times -40. And when you're using one of these calculators, it's kind of easier if you know your positive and negative rules, because you can just do 4 times 4 without hitting a weird, what did I just hit? 4 times 4, there we go, times 40. And you don't have to worry about the negative or the positive or anything, because you know it's going to turn out positive. So 36 plus 640. And then over, I'm going to go ahead and do 2 times 4, because it's not going to hurt anything if I go ahead and get that over with. Over 8. I'm going to go ahead and keep going. -6 plus or minus. And then the next thing you're going to do is go ahead and add these together. 676. And we'll take that square root in just a minute. Over 8. Now, sidebar, the part in square root will tell you how many solutions you're going to get. Okay, so if the part in the square root is a positive number, you're going to have 2 real solutions. So I'm going to write that up here. So this part, b squared minus 4ac, is a positive number, then you're going to have this scenario. If you have b squared minus 4ac is 0, then you're going to have 1 real solution. And if b squared minus 4ac is negative, of course you can't take a square root of a negative number. There's no real number that would answer that. But there are complex numbers. Then you're going to have this situation where your quadratic doesn't actually touch the x-axis, and you're going to end up with 2 complex solutions. So when we're looking at this one, my square root is of a positive number, so I know I'm going to have 2 real solutions. So that at least shows me what to look out for. All right, let's keep going. Once you've simplified this, go ahead and take your square root. Okay, so 676, and then square root, and you get 26. So x equals -6 plus or minus 26 over 8. And then from there, you are going to do this, as I was saying earlier, I think that's when the announcement came on and I got interrupted. You're going to do this twice. -6 plus 26 over 8, and then -6 minus 26 over 8. So let's do that. X equals -6 plus 26 over 8, or x equals -6 minus 26 over 8. And then let's see what those are. And when you're simplifying a fraction, go ahead and do the top and then divide. So I have x equals, this comes out to 20 over 8, which simplifies to, I can divide them both by 4 and get 5 halves. So there's one solution. Or -6 minus 26 is -32 over 8, which comes out to -4. So my 2 solutions are 5 halves and -4. All right, let's try another one. In fact, let's try one that is not in the correct form yet. So here we go. So this is not in standard form. Let's get it in standard form. Remember, it needs to look like this, with a 0 on the right and all your like terms combined on the left. Okay, so I can go ahead and subtract 10x squared, and I can go ahead and add 10. I'm going to go ahead and do this in one step. You do not have to. You can break it up if you prefer. These cancel, and these cancel, leaving me with 0 on this side, which is what I wanted. And then 13x squared minus 10x squared is 3x squared. Negative 118 plus 10 is negative 108 equals 0. Now, as I kind of briefly mentioned earlier, if there's no linear term, this is the linear term, because it's just coefficient x. And if you were to graph that by itself, it would make a line. That's why it's a linear term. There's actually an easier way to do this than the quadratic formula. So I'm going to show you both ways. So let's do the quadratic formula way. And you can always use the quadratic formula. It's never going to not work as long as your equation is in this form. So if you see both ways here in a minute and you're like, Miss P, I don't understand, it's too confusing, then that's okay. Just for now, you can use this. It's not going to fail you, I promise. I put easy in quotes because I don't want to make anybody feel bad if you don't find it easy. But I think it's easier. Okay, so quadratic formula way. So I have x equals, and then flip over your page if you need to. In fact, let me. So again, here's your quadratic formula. If you want to rewrite it, then go ahead. Okay. So x equals, and then I'm going to do negative b. Now, I don't have a b term, because that's my linear term. So everywhere I have a b in the quadratic formula, I'm just going to put a 0. So 0 plus or minus square root of b squared, 0 squared, minus 4 times a times c, all over 2 times a. So a, c, no b term, b equals 0. Okay, so this makes it a whole lot easier to solve this because the fact that we're taking 0 plus a number and 0 minus a number, it's 0. Okay, so that's going to lessen our work, which is really cool. We like not doing work, don't we? So 0 plus or minus. All right, so here, again, we have less work because 0 squared is still 0. So you just have to worry about 4 times 3 times 108. And the two negatives are going to cancel each other. Okay, so 4 times 3, which is obviously 12, times 108 is 1,296. So positive 1,296 over 6. Okay? And we know from what I discussed on the front of my page that if this number is positive inside of here, then I have 2 real solutions. So I'm going to be looking for 2 solutions this time, just like last time. Okay, 0 plus or minus. I'm just going to rewrite this as plus minus square root of 1296 over 6, because I don't really need the 0 anymore. And then let's see what is the square root of that. So I have 1296 square root is 36. So plus or minus 36 over 6. And this is going to turn out real nicely for us because 36 divided by 6 is just 6. So plus or minus 6. And when you see plus or minus, that just means your solutions are x equals positive 6 or x equals negative 6. Okay? Okay. So that's the quadratic formula way again. Now, since I have no linear term, there's an easier way to do it, and let me show you that just in case you might like it better. But you can't always use this. You can only use it when you're missing that x term, okay? When you're missing the b. If the b is there, then you can't use this way. All right. Now, since x is in only one spot, not 2 separate spots, all I really have to do is my reverse PEMDAS that I use when solving other types of equations. So I'm going to start with add or subtract. So I can add 108 to cancel it out. So 3x squared equals 108. And then when I'm done with any addition or subtraction I need to cancel, then I can move up to multiplication and division. So I can cancel this 3 times x squared by dividing by 3. And 108 divided by 3, let's see, that's 3, 6, so 36. And then we're going to move up to the exponent and think, how do you cancel squared? And I sure hope you said either with a square root or with a 1/2 exponent, because they are the same thing. Okay, and then that leaves us with just an x here because the square roots cancel. So x equals the positive and negative square root of 36. Make sure you include both. So that means x equals plus or minus 6, which just means x equals 6 or x equals negative 6. So that is 2 ways to solve a quadratic that has no linear or b term. You can use quadratic formula, or you can just kind of take the square root of both sides after you cancel out any addition, subtraction, multiplication, or division. Okay, let's try one more. Okay, so here we go. Now, first things first, I need to get this equation into this form right here. So I'm going to try to bring everything over to the left so I can have a 0 on the right. Okay, so I kind of wrote everything at once that I'm going to be doing. I'm canceling out the negative 9 by adding 9. Now, there are no like terms with 9 on this side of the equation, so don't try to add it in with anything else. It's just going to hang out there at the end. It's going to kind of be right here. It's the c term, okay? So don't try to combine it with x or x squared. Then I can subtract 8x squared from both sides. Then here's the like term right there. And then I can add 12x, and again, here's the like term, so I'm going to combine it right there. So 14x squared minus 8x squared is 6x squared. Negative 6x plus 12x is 6x, and then plus 9, because it doesn't have any like terms. And then on the right, I canceled everything, which was kind of the whole point, and I get 0. Okay, then I'm going to plug this into the quadratic formula. So x equals, here's your a, b, c, and they're all positive this time. So negative b, which means negative 6, plus or minus square root of b squared minus 4ac all over 2a. And then start simplifying. Again, start with squaring and multiplying. So x equals negative 6 plus or minus 6 squared is 36. And this time this is going to stay negative because I'm multiplying a negative times positive, so the result's going to stay negative. So I have 4 times 6 times 9. And I get 216. All over, and 2 times 6 is 12. You can go ahead and multiply that out, that's fine. Okay, now I'm going to go ahead and work out to the side because I don't want to run out of room here. Negative 6 plus or minus, now go ahead and subtract these two. And you'll notice it's going to turn out negative. So 36 minus 216 is negative 180. Over 12. Okay, so this being negative right there, it means I'm going to have 2 complex solutions and no real solution. So I'm going to have I in my solutions. Now, if I try to take the square root of this on this Junktastic calculator, pretty sure it's going to return, yeah, it's going to return an error. So these guys aren't going to do it. The inspires will if you change the settings on them to allow complex numbers. But it's really not that big a deal to just deal with it yourself. And here's what I mean. You guys already know how to simplify square roots because we learned that earlier in the year. You're going to have to make your square root tree. So remember back when we did this. 180 is 18 times 10. And this is 3 times 6, 2 times 5, and 2 times 3. Then you circle your pairs of factors. And then anything here that does not have a pair, it's going to stay in the square root. And the ones that are paired, you're going to kick out one of the pair because you square rooted it, and then multiply what's left over. So that gives me still the -6 plus minus. That hasn't changed yet. And then this guy, this negative, the square root of a negative, square root of -1 is I. So you're going to take the 3 times the 2, which is 6, put an I next to it to account for the negative. That's an I. We usually use a cursive I. In electrical engineering, by the way, they use a J for the same thing. It's just, they call it a J because they already use I for something else. And then the 5 stays in there. So over 12. That's what we got so far. And then I just need to simplify this. So I can go ahead and divide all of these by 6 right here. I'm going to divide by 6, divide by 6, divide by 6. So that gives me -1 plus or minus I square root of 5 over 2. And you can actually leave it that way if you want to. Like, that's a perfectly good way to write that solution right there. Or you could separate the plus and the minus versions if you prefer. It's really up to you. As long as you recognize both, it's your choice. Okay, so either way. Let's look at one more that I'm not going to tell you how it's going to turn out. Let's see how it turns out. So first, I do need it in standard form. So I need ax squared plus bx plus c equals 0. So I'm going to go ahead and cancel the 4 by subtracting it. So make sure you subtract it. Remember, it's not like terms with any of these, so it's just going to kind of hang out by itself. And then plus 10x to cancel this. And here's the like term, plus 10x right here. Let's see how we get here. So 9x squared. These cancel again. And then minus 4 equals 0. There's actually 2 different ways we're going to go about this. So we can use the no linear term easy way. Or we can do something called difference of squares, and that's going to kind of lead us into the next method. So let's do the no linear term shortcut again. Okay, so I'm going to start with my equation, and I'm just going to go ahead and use order of operations in reverse. So I'm going to add 4 first. 9x squared equals 4, and then divide by 9. Then I'm going to take the square root, and I would leave that as a fraction because both of these numbers have a nice integer square root, the 4 and the 9 do, so we're going to get a nice fraction out of this. So that cancels. That means x equals plus or minus. And then to take the square root of a fraction, you can just take the square root of the numerator and the denominator when it's really nice like this. In fact, let me write it up here. We're just going to do that. Okay, so square root of 4 is 2. Square root of 9 is 3. So that means our solutions are positive and negative 2/3. So x equals 2/3 or negative 2/3. And that's it.